All right, welcome back to Lag Demon Programming. I'm Bill Westlake, and we are working on the compiler design course. However, I'm going to step back a little bit from the compiler design because very soon here we're going to start turning our game into a multi-user online game. And to do that, we're going to need to work with a couple of different things. The first most important thing we're going to have to deal with is multi-threading. Multi-threading can be a little bit complex. Fortunately, it's a little bit simplified by the standard library. We are using, I believe, we are using C++. We're using the standard 17. So we've got access in C++ 17 to a lot of interesting capabilities. And so we're going to talk a little bit about multi-threading and how to use some of these standard library functions by starting off with something very simple. Hold on here. Let me check. Okay. Here's the one I want. All right. All right, so what we're going to do then is we're going to go ahead and create a, we want to do that. We're going to create a folder here that we're going to call threads. And of course in threads, we need our C make lists.text. This is a fairly simple one here because we're going to start off by adding an executable so we can just run this. Later we'll change it into a library. For now we'll just call it threads, and we're going to have two files. We're going to we're going to start off with a threads.cpp file, which is going to be our main file, and we have to add in our target link libraries for threads, and the target link library that we need for this is called pthread. It has to be linked in because we're going to be using the standard library threading functions. In our top level one, we just need to add that directory, so we'll add that, not definitions, add subdirectory, come on. Why did I lose my IntelliSense there? Threads, okay. Add subdirectory threads, and then here in threads, what do we have a problem here? Threads, because we don't have the CPP file probably. So let's add that. Add executable threads. Well, it's there now. It'll find it eventually there. It finally found, no. Let's go to threads.cpp, throw in a main function real quick. Main, int, main, void, turn 0. And let's try to do a make sure this builds, cd build, make. Okay, it built. I don't know why that's still having trouble finding it. That's an IntelliSense problem. All right, so what do we want to do? Well, we're going to go ahead and include our IO stream so we can print some stuff out to the screen, and we're going to include thread. And we're also going to include mutex. All right. So the first thing, not text, it's mutex. All right. So the first thing I want to demonstrate is a thing called race conditions and possibly even deadlock conditions and what they're all about and what they mean. So let's first try to create some threads and simultaneously have them updating some state. Let's create some state. We'll call this integer state 1, and we'll set it to 0. And we'll have state 2 equals 0. All right. Now, we want a thread function. We want a function that's going to update that thread, or excuse me, update that state. So let's call this update state thread. And what's it going to do? We're going to do this. We're going to go while true. We're just going to run forever with this. And we're going to say state 1 plus plus and state 2 plus plus. Simple. Then we're going to have a function here that we're going to call read state thread. And this function's also going to do a while. Understand, this is not the way you should do this. What I'm trying to do here is create a race condition and show you what a race condition is, and we're going to see how we can avoid the race condition and make sure these two threads work in lockstep with each other properly. So we're going to go while, we've already got while true. What we're going to do then is go, we'll just do this simple, we'll go standard cout from state 1 from, we'll put a space, state 2, all right. Now down here in main, we want to create a couple of threads to run on this. So we're going to use this object called standard thread, and we'll create, we'll call this update thread, and we'll go update state thread. We'll just pass it the function. Because this is just a very, it's not part of an object or anything, this is all we have to do. There's a little bit different way we'll use this when we do this inside of a class, but for now, this is the simple way. And so we'll create another thread. We'll call it read thread, and we'll call it read state thread. All right. Now that's also going to start those two threads. So what we want to do is go update thread dot join and read thread dot join. So that'll cause the main thread here, not read state, read thread dot join. So this will cause the main thread to wait until those exit, which they never will. We'll control C out of it. Let's run it and see what happens. Let's do a build. So it built. Threads, and see instantly we get huge numbers. All right. So what we're going to do is put some delays in here. And the way I'm going to do that, let me take a look at my notes just to make sure. So in between these two here, we're going to put a delay. The way we're going to do that is by using this thread, sleep 4, we'll use milliseconds and about 100 milliseconds in between those updates, and then another 100 milliseconds after this update. And then here in this read, we'll also read and then wait for 100 milliseconds. So let's see what happens here. It's going to go much slower now. So it's going slower, and if I stop it, we'll notice that sometimes, so here it says 1 0, here it says 1 1, then 2 1, 2 1, 2 1, 3 2, 3 3. They're both the same, 4 3. So this is what we call a race condition. So what's happening is that this function is updating this state, and this one's reading it, but they're doing it interleaved. And so this is updating this state, and then this is reading both of the states, and then this is updating the state here, and so that they're out of sync. So the idea is this should update the state completely before this can read it. So what we want, in other words, this state update to be atomic. Now, this is global mutable state, which is bad in the first place. So this is really not the way to do it. And obviously, we have a race condition. We can see here the state's not always in sync the way it should be. So how can we avoid that problem? Well, we can do that, first of all, by using a lock guard. And the way we're going to use this lock guard is we're going to put a lock guard around this by first putting this in its own scope. We're going to come up here and we're going to create a mutex. And we'll just call it mutex. And inside here we're going to create a lock guard. L-O-C-K. There it is, lock guard, and it's going to use standard mutex as its locking agent, and we'll call it lock, and we'll pass in our mutex to the constructor. So this is a local variable, but it's within this scope. So when this scope exits, it's going to get destroyed and unlock. So that'll happen automatically. When this enters this scope and creates this, it'll lock it. Now what that locking means is if it's the first one to lock it while it's locked, everything's fine. It'll run all of these statements. If something else tries to come into this mutex, same mutex through a lock, it'll wait until this unlocks. And we're going to do that right here by placing this one also inside this. We'll put this delay outside the lock, and we'll do this same lock guard at the beginning of this one. Now, what will happen is, while this is updating both of these, this is locked. When this comes around and tries to lock it, it'll wait on that lock until it unlocks when it drops out of scope. When it drops out of scope, this object becomes destroyed, automatically unlocks the mutex, comes back around. This thing's got it locked while it's printing it out. As soon as it unlocks it, then this can run and update it. Now, these two states should be in lockstep all the way, if I've done this correctly. And let's run it, and let's let a bunch of them print out here. And we can see that now that race condition, which we saw up here, which was creating these odd state updates, is now in lockstep. It's updating both the states in sync every single time with no errors or issues. Now, deadlocks. A deadlock can occur when a function like this locks this guard and doesn't unlock it for some reason. For instance, had we put this outside this scope in this loop, this loop would lock this. This would not be out of scope. It would come around and it would lock it and stay there, and this guy then would lock this and stay there, and we'll be in a deadlock. Let's test that. I'm pretty sure that this will create a deadlock, which will do nothing. So now the two threads are deadlocked. The top thread, the update state thread, deadlocked itself, keeping it so it's frozen at that lock because it looped back around and locked it again, and it said, I can't use this, or I can't go any further. Then when the read state thread came into the lock guard in its thread, it locked that mutex and it locked as well. So neither of the two threads are running, and that is what a deadlock is. So that was pretty easy to demonstrate. Let's move this back to here. And we've got these set to 100. Let's move these down to 10. 10 milliseconds here, delay, and move this to 10 milliseconds. Let's see if this thing runs a little faster. It runs pretty fast. Let's eliminate the delays entirely. Now, this might be a problem. We'll eliminate this delay. Let's take all these delays out and see how it behaves, and then see if we have to tune it. So it went super fast, and if we look up here, 4377062, 4377062, it went extremely fast, no delays, and it's in complete lockstep. If we were to go through here and print this out, in fact, you know what we could do is we could have this reading this state, and we can only print it out if they're different. And so if we take out, what we can do here is go if state 1 does not equal state 2, then we'll print out. And to experiment with that, let's take our lock guards out. Now it's only going to print them when they're different, and we can see there are a lot of them are different. We're getting tons of different stuff out of here. So now if we do this, it's only going to print them when they're different. So this shouldn't actually print anything out, and it's not printing anything out. We could come down here and go else we could just print out, get rid of this, print out OK, and get rid of this. Oops. Here we go. And now it's just constantly printing out OK. And we don't see any numbers printed out, so that's working. So that's how that works. Okay. Now we want to use these lock guards. Oh, there's one other thing. Well, I'll go over it when we start doing it in the class. It's called a condition variable. Condition variables are used very similar to lock guards. They allow you to wait until you're signaled to move on for something. So that's what we're going to do next. Let me double check the time here. So it looks like we're 19 minutes into this video at this point. So I think I will stop the video here, end the video here, and we'll pick up building a thread class of our own that handles message passing and callbacks and so forth in the next video. So thanks for watching. I hope you enjoyed it. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I will see you in the next video. Thanks for watching.